I'm Karl Wilber. I'm with Tekran. I've been around for a day or two. I don't need to give a background, but I've been with Tekran for 18 years and have been involved with primarily mercury measurements, Mercury CEMS there, and prior to that, some plant testing, some expert witness work, worked for a company that provided air pollution control equipment for sulfur dioxide and NOx, et cetera. And so I bring with me a little bit of different background, but some experience with Tekran and some experience in trying to see how do you make instrumentation for ambient air, laboratory, and in this case, CEM systems. Let me involve the audience just a second for a couple quick questions, just a raise of hand. How many people own Mercury CEMS? So we've got maybe a dozen. How many people sell Mercury CEMS? More than that, more than the people that own them. Okay, well it's a classic market dynamic. Yeah. All righty. So we're going to talk about some ways that might be inexpensive ways to improve the potential QA/QC of Mercury CEMS. I've got 6 parts to this, which we'll go through. The first one's kind of provocative, if you will. In the EU, you need TÜV certification to play in the game. And also, you need to have low-level measurements because a lot of the emissions limits are around 1 microgram per cubic meter or less. So you need to focus on that. You need to look at the sampling path. And one thing that is missing, but the EU is working in a number of parallel pockets and then coordinated pockets. Thank you, Iris DeFrome and others like VSL and NPL. And there was a gentleman from Finland doing research on traceability, extremely important. But in the EU BREF regulations, you don't necessarily have to have comprehensive calibrators going over a range of concentrations with calibration. So, and then if you do have a calibrator that's traceable, how often does that need to be recertified? There's a lot of stuff going on with mercury measurement. We don't need to go into the science, but it's not that easy necessarily, and because there's multiple species, the oxidized mercury can get lost along the way, and that can be an important aspect. The detectors only measure elemental mercury, so you need to do some conversions. And when we talk about Mercury CEMS, if you wanted to add some QA/QC to an EU CEMS, you could have a generator. We have one of those at our booth that generates oxidized and elemental mercury, and you can make it traceable to NIST or another standard. In fact, it just went through some VSL testing. You could have a saturated source, and you could have a permeation source. And so there's a lot of ways to add additional bells and whistles. And let's say you had 2 of those sources and you thought you knew something about how they work. You can do a ratio of those 2 sources and see if that's constant with time. In the US, Jeff Ryan, you know that, that perm source ratio and the calibrator output needs to stay within 5% over time. And if it doesn't, it raises flags. All right, you can do various calibrations. You can calibrate the analyzer directly. You can do spikes on the system to see, okay, you're running along at 1 microgram, let's spike it with 5 and see how it responds. That's another QA/QC thing. You can put mercury upstream of the probe filter and do a system calibration. And as most of you know, these are heated lines. They're around 180 C plus minus 10 or so. And to do a system calibration is important, especially if there's oxidized mercury, because you can get losses along the way. How do you know if there's losses? What are they? How do you know if your lines are heated properly? So you do a system calibration. And so you can attack these systems at multiple locations and check point by point how they're doing. We use mercury generators to generate gas for electric generating units. For electric generating units, They're typically 0 to 10 or 0 to 5 micrograms per cubic meter range, and a lot of them are running around 1. To the professor's point, what range should you calibrate those over? And in some cases we've run into, there's low mass emitters and what they call low emitting EGUs. They can be 0.1 microgram per cubic meter. So it's important to have that range of investigation. In the cement industry, you have mill on, and a lot of things get scrubbed out of the flue gas when the mill is on. It's a nice wet environment, and so oxidized mercury gets trapped and accumulated. Then you shut the mill down for the weekly or every 10 or 14-day maintenance, and poof, there's a huge expulsion, if you will, of oxidized mercury. In fact, in the US regulations, in the cement industry, there's a total limit, or there's a pounds per million BTU, or a million pounds of clinker, is it pounds per million? 1,000? In any case, it's a ratio situation. With the mill down, that emission of mercury is greater than the 90% of the days where the mill's on. So it's an important thing to factor into how do you do that measurement, how do you preserve the sample, how do you minimize losses of oxidized mercury. Let me move on from there. There's the traceability triangle, we know that, and we don't need to go into detail there, but NIST has some traceable sources, and there was a great side seminar before this conference that VSL put on that involves traceability. This is the VSL schematic, thank you VSL, that shows basically you have their standard and it leads to these, what we call vendor primes in the US, and then there's certified, there's field reference generators, and then there's the ones in the field. And the question is, if those are certified, if they're traceable back to NIST, how long do they last? Do they last a week, a year, 2 years? One way that we determine it on our systems is we do that perm source ratio. You have an embedded mercury source. You have a generator that is traceable to NIST. One of these down here. One of these generators is traceable to NIST. And as long as the ratio of those two stay within 5%, and we check that 2 or 3 times a week, then you assume its systems go. And if something goes wrong, you have to get a new generator in there and replace the one that looks suspect. There's different calibration ranges depending on whether you're an electric generating unit or a cement plant. And for electric generating units, the NIST range, and there's a lot of focus in this range right here since the limits are about 1.5 micrograms per cubic meter for emissions. Those are the NIST points that you would get for your generator, for your vendor prime. And then if you were dealing with cement, as I mentioned, with mill down, you may get a lot higher concentrations you have to deal with. Sampling. There's the wet chemistry, the previously called Ontario hydro method that people have used. More commonly in the US, sorbent traps are used. In fact, even in the case of NIST, they've used this sorbent trap method to look at the apparent concentration when you're getting a certification for your generator, and this is telling you what the answer is. And Jeff Ryan and others have been instrumental in invoking the sorbent trap system. I think that's getting some traction, David, in the EU, the sorbent trap method, and I can say it's easier to administer, a little quicker, a little cheaper. You can do 12 tests in 3 days, and you go in with equal area traverses and 4 different perpendicular radii, and you can do these tests, and of the 12 tests, you can throw 3 out the window if they look funny and keep 9, all right? So it's kind of a nice way to do that. And if you can also have a sense of whether there's any breakthrough of your sample. That's a schematic. We don't need to deal with that. Another inexpensive thing you can do for QA/QC is you can establish remote connectivity. Plants don't like a lot of people being able to dial in without some kind of multiple level security and authentication. I get that, but we have well over 100 customers that have us dial into their systems. Get somebody on the phone rather, get them on the internet and connect to the system. And this is an example of a form we might use that has, what are the temperatures of the probe? What's the generator look like? These are two different generators, an oxidized and an elemental. What do those look like? And then somebody signs it at the end, but you can look at various calibrations and you can alert the customer something's going wrong with your system and leave them a message after you do this audit. So a very inexpensive way to do QA/QC is have a knowledgeable person that's dialing into the system, and it can be a plant person, it can be a management person. We don't have a lot of regulatory people that dial into the systems, but there is regular reporting in the US versus other places that the environmental management groups can dial into. Now, these are notes. I asked one of our customers to say, what's your experience over the last 15 years with Mercury CEMS? And this person that bought a dozen CEMS in 2008 said that they are consistent with the EPA NIST traceability protocol. They do the daily zero spans. They do the weekly integrity testing. We do it actually for our customers a few times a week to see if something's drifting off. The percent monitor availability, which there's an equation for, but it's basically what's the uptime and is it good uptime, at 99%. And the RADAs with the sorbent trap systems primarily, typically within 10% and about 0.3 micrograms per cubic meter maximum difference. So they've had a decent experience over 15 years. And of course, I like to pick the best customer to have a story. I don't want to tell you other problems. I'm joking. But so people have had decent experience with that. And let's do something provocative here. Traceability is an important thing. And let's say somebody has a handheld monitor for a workplace. And by the way, these are true stories. And they test that work air to see if it's okay for their employees to enter that. And they have a traceability thing, and it's different than somebody else's traceability. But as Iris de Chrome said, we want to harmonize these measurements. We want to make sure if you're measuring X, that it's X and not Y, and it's apples and apples. And in this case, the handheld generators were 25 to 30% off. So the question comes up, was it safe to go in or not? So traceability is important for something like that. The second example is the onboard reference generator was found to be 20% in error. And so is it in compliance? Is it not? When did it go wrong, et cetera? And sometimes if you get a certification that says everything's good for 90 days, you need to understand whether the train goes off the rails on that. A third scenario is that somebody fails a relative accuracy test audit. In the US, they're required annually. All right, so it's like the Super Bowl, if you will. A third party comes in, they test it, it has to meet certain requirements, and if it doesn't pass, then you have to do it again. And sometimes people have to do it 2 or 3 times because there's a question of either the test method or the CEMS. So it's important to have traceability, it's important to have ongoing QA/QC, and if you don't have it, then it can lead to expense, additional expense. And in the case of the CEMS used for the process monitor, I didn't want to bulldoze over this, but a lot of places in the US use activated carbon to further abate mercury. Some of the plants inject $750,000 to $1 million a year of activated carbon. If you're off on your CEMS and they're using that for a process monitor or a tool, and they're off 20%, well, 20% of $1 million is a pretty big number. So you want to make sure you're right. You want to make sure you have consistent measurements, that the QA/QC is there. And at the end of the day, this may not sound like it. Somebody has to have a Mercury CEMS on their site. First of all, they probably don't want it. I mean, let's face it, they're not rushing to get, I want to meet the compliance thing and I want to spend another $100,000 on this and the installation and all that. They don't want it. But if you have it, you want to make sure it's accurate, and you want to make sure if you're controlling mercury that there is a traceability of your measurements and that you're not wasting money blowing in additional activated carbon. The sidebar of that activated carbon, you blow in too much and your fly ash is used in part to recycle and use at a cement plant, if you have too much activated carbon, you can't sell it. All right, so there's a lot of implications, and this traceability and this accuracy thing turns into an economic situation. And so it's important to be accurate, traceable, and there's a lot of simple ways to do that to improve the performance of your systems. I think that's about it. In the EU, at least for the measurements we're involved with, you don't have to have a comprehensive traceable onboard generator today. Is that right, David?
No,
you don't, okay. Yeah, the manufacturer decides. If you're a manufacturer and you want to sell in the marketplace, a lesser cost scenario is take that out of there, because I don't necessarily have to have it. I can put some other mercury sources in there and test it and have some QA/QC, but it's not required. But there's talk now about traceability, about having calibrators or generators on board. And people have already purchased, many of them, CEMS systems. They don't have these, or they're not traceable to a known source. And my question, I'm jumping to the end, in this marketplace in the EU, do we have a cart before the horse? Are people being asked to do certain things with equipment that's TÜV certified? And TÜV does a great job of putting things through the paces. Are they being asked to do that? But when the system goes into the field, is it traceable? Are there QA/QC things that need to be done that could enhance the performance and the economics of that, if you have to have it? And so there's a little bit of a cart horse thing. And Jeff Ryan can attest, in the US, we spent probably 3 years working on NIST traceability and EPA protocol, more than that, 5 years, and coming up with various things. That, unfortunately and fortunately, the Clean Air Mercury rule was knocked out of the books. It was illegal, it wasn't stringent enough, and we came up with new rules. So we had that period, Jeff, where we could work a little bit more on traceability and QA/QC, so there was a benefit to the user, and the outcome was improved as a result. All right, so cart horse situation. Final slide. Mercury CEMS are used for compliance, and they're also used for process control. Make them accurate, perform QA/QC, and I'll just jump to the last one. Lack of traceability can be costly and misleading. So thank you for listening to this, and we'll entertain questions for the three speakers.